Alright, and we're... Oh, shit. And we're streaming. Let's go. Okay. Alright, we're going to see how fast we can get through this through these various problems in circuit theory. We're going to start with nodal analysis. We have maybe like, let's see, 9 pages, 1 problem per page. 9 problems. So we have 9 problems. Let's see how fast we can run through them. Okay. Timey. Okay. We got a power supply running in series with a resistor. A resistor in series with a power supply. Another resistor running to a current supply. Bang. Yeah. Okay. Yep. Like that. Okay. Resistor. Bang. Right here. Resistor. Again, we're using nodal analysis. Bang. Another resistor. Just like that. Tossing over here to this resistor. Let's follow this line. Yep. Just like that. Oh, shit. There's one more right here. Just like that. Okay, let's put down the values, magnitudes of these resistances. In ohms is the unit, 2.5. I'll put 1. I'm not going to put all of them, though. Ohms, 50. Bang. 5. Bang. Let's see. 2.5. 2.5. We need to know some parameters in order to solve for the system. You can't solve for, 1, 2, 3, 4, 5, 6. That would be 6 more variables. 1, 2. Yeah, on top of it. 8 variables at least counted right here in this problem if we weren't given these parameters that we would have to solve for, and we can only essentially make 3 equations. I think we're going to make 3 equations. Alright, we'll see. 640. Just by looking at this problem, doing a quick analysis in the mind, I think that we are going to have 3 equations to solve for this, because I'm seeing 3 nodes. Right, this one's known. This node is known. That's 640 volts, which is our voltage supply. Wait, let's finish this first. Wait, we got a couple more things to draw now that we've been given. Amps, V1, bang, V1. We have what's going on here? Positive. Where's the negative? That's weird. Okay. What the fuck? Alright, plus negative, positive, negative. That's V3. I think it goes positive. It's kind of hard to tell. V2. I think it's messed up, the drawing. Okay, so this is accurate. This is everything we've been given. Okay, now let's begin the nodal analysis. Which nodes do we not know the voltage of, right? Because a node is equivalent to volt. Well, no, we're going to use Ohm's law. Node, we're going to use KCL, Kirchhoff's current law. We're going to use Ohm's law to get our node equation, to get our node formula. Yeah, equation. That's what we consider it. All right, this node is 640 volts. We're going to call this E1, E2, and this one E3. Yeah, that works. Okay, 12.8 amps. That'll come into play, but not right now. Okay, so let's write an equation for E1. So the equation for the node at E1 using KCL is, let's see, E1... we'll draw it out too. We'll draw it. So, oh, actually, no. Let's make that going this way. My bad. Like that. Oh, what do we have? Oh, we don't have anything here. Like that. Probably like that. And positive, negative, like that. That's how we want to do it. Like that. Oh, I didn't need to draw him. We'll draw him now. Going outward also. Positive, negative. Yeah, probably. So also going that way. Okay, so we'll call him IN. We'll call him I1. We'll call him I2. Okay, so the equation for node E1 is IN equals I1 plus I2. I1 plus I2, right? This is using KCL, right? Because we have one current entering the node, and we have 2 exiting. So we're gonna essentially apply. If we're entering the node, if the current's entering the node, do we want it to be positive or negative? All right, so in this scenario, we could choose either. We could choose negative, right? So negative, and then that would mean those currents exiting the node would be positive. All right, so imagine we had I1, I2 are positive, they're exiting, and then we have IN entering. That would be a negative on this side of equation equals 0, right? This is the the conservation, this is the sum, essentially equals 0. And so if we had that, we just move it to the other side and we get a positive IN. Right, so that's where that comes from. Okay, so that's our equation. And then now using Ohm's law, we can say that, okay, what is IN? It's 640 volts minus E1 divided by this 3 ohm resistor, 3 ohm, sure, I'll put it, equals I1. I1 is E1 minus E2 divided by 2.5. E1 minus E2 divided by 2.5. I'm not going to put the ohms. Plus I2, which would be I2. I2, where's my ground? It doesn't specify, but I have to. It doesn't matter then. Maybe it doesn't matter then. I kind of want to put my ground here. So if that's the case, E1, oh, that would be another node. Imagine I put my ground there. Then that would be a node? No. Negative 640? No. No. So that's another node. Okay. Alright, fine, we'll do it. We'll make it another node. And we'll say that he's traveling this way. Okay. That's another equation then. I don't like that. I don't like that at all. It's another equation. Not a big fan. Okay, that's alright. Plus I2, E1 minus E3. Alright, E4. E1 minus E4. Man, it's a lot of equations. Divided by 50 ohms. Okay. 50 ohms. Alright, yep, that's one of our, okay, so, alright, I1, that's going out, this is going out, everything's going out, I1 plus, oh wait, that's I1, it is, I1 plus, I1, I2, I3, and, yeah, okay, so I1 plus I3 plus 12.8 equals 0. Okay, I1, what's I1? I1 is E1 minus E2. E1 minus E2 divided by 2.5 ohms, 2.5, plus I3. I3 is this current here, which is E2 minus E3. E2 minus E3 divided by this resistor that it's flowing through, 5 ohms, plus 12.8 amps. Equals 0. Okay, equals 0. Let's see, E1, E2, E1, or E2, E3. Let's see, E1, E2, I have E4. Yeah, E4, shit, okay. E2. It is a node. What about it? I mean, that's it. I1, I plus I3. Okay, I don't know. Alright, let's write the rest of our equations. What, we have E3. E3, E3. Okay, I guess we could label them. I3, I3, that's coming in, this is going out, this is going in, I3, I4. Do I have that yet? No. I3 plus 12.8 equals I4. Okay, I3 again. We already have this wrote down, right? I3, E2 minus E3 divided by 5 plus 12.8 equals I4, E3 minus E4, E3 minus E4 divided by 2.5. Okay, alright, now we just have E4, we have this current, I5, and that equation looks like this. How far can we see over here? Well, it's getting really bright. Okay, that's gonna look like this. So I5 is exiting. I5 equals I2 plus I4. Okay, and then that equals I5. E4 divided by 2 equals E3 minus E4 divided by 2.5. Holy smokes, it's taking a long time, isn't it? Plus I4. Oh, that was I4. I4 plus I2. E1 minus E4 divided by 50. Was there a better way I could have done this? If that was 0, that would have had that. Would that have been negative 640? If I would have made this a node and made this ground, would that have been negative 640? No, it wouldn't have. It wouldn't have. That would have just been another node. So I would have had 4 equations regardless. Alright. Fuck, it's a lot of work. Alright, 640, 640 divided by 3. Oh, where's my, oh no. I need my calculator. Shit. Okay. 640 divided by 3, 213.33. Can't see that. Yeah, 213.33. Okay, minus 1/3 E1 minus 2.5 E1. Let's see, plus E2 plus 2.5 E2 plus, no, okay, but that's everything would have to change. Minus 1/50th E1, bang, okay, equals negative E4 over 50, whatever, we'll write it like that. Okay, everything is gonna have to change essentially, so E4 equals 50 multiplied by negative 213.33 plus, okay, so plus E1 multiplied by 1/3 plus 2.5. Ah, shit, is that a minus 1/50th? Yeah, it would be. No, yeah, it would be minus. Yeah, so it's gonna be plus 1 over 50 minus 1 over 2.5. Truly, yeah. So these are gone, and that equals times 50 equals that. Negative 10,666.5 plus 50 multiplied by 1/3. 1/3 plus 1/50th. Okay. Times 50. Plus 17.667 E1. Okay. E4. Wait a second. Oh shit, wait a second. E4. Oh. Wait, what happened here? Oh, no. Okay, wait. Plus E2, 1 over 2.5. Is it a plus though? E2. Nah, it'd be a minus. Damn, I fucked that up. Ah, shit. Fuck that up. That's okay. 1/3 minus 1. Wait, yeah. Is it a minus? No, it's still a plus. 1/3 plus 1 over 2.5 plus 1 divided by 50. Okay, times 50. Ooh, okay, plus 37.667 E1 plus 1 over 2.5 times 50. 2.5 times 50. 20 plus 20 E2. Fucking minus 20 E2. Ugh. No. 37.667. Shit, is that right? That looks right. Okay. That'd be a minus. So that was so I was supposed to subtract that E1? No, plus. Minus. Yeah, it'd been the positive E1. Oh, minus 1 over 2.5. Yep, that's where it comes from. Okay, E2. Alright, shit. I almost fucked that up. Well, should we do this or should we just... Oh, man. Maybe I should, Wait, let's make it a system of equations. Shit, yeah, I should have did that. Let's just do that instead. So equals plus 213. Okay, so equals 1/3 plus 1 divided by 2.5 plus 1 divided by 50 equals that. So 0.7533 E1 minus 1 over 2.5 E2 minus E1 over 50 E4. Yeah, just like that. Okay. Yeah, let's make a system of equations. It's going to be so much better. It's going to be so much better. Let's see. What do you guys got going on here? In CAD later. Electronics theory, bitch. Okay. And on good lighting. Yeah, okay. So there we got that. Okay, that's one of our equations. What else? Now we can do this one next. 12.8. So 12.8 equals 1/5 plus 1 over 1 divided by 5 plus 1 divided by 2.5. So equals, right, positive E3, yeah, positive 0.75. 0.7533 E3 minus 1/5 E2 minus 1 over 2.5 E4. Okay, that's our second equation. Let's see, 12.8 again. 12.8 equals so minus 1.1 over 2.5, negative 1 over 2.5 E1. Let's see, plus E2 plus E2 minus E1. So plus 1 over 2.5. Wait, 1 divided by 2.5. 1 divided by 2.5 minus 1 divided by 5. 0.2. 0.2 E2. Okay, plus 1/5 E3. 1/5 E3. Okay. And last equation, our fourth and last equation, it just equals 0. So 0 equals, and then I'm gonna go get my calculator and type this into a matrix. It's gonna be the best way, and then solve through like Kramer's method or determinants, whatever. So E4, E3, E4. Let's see, E3. We'll start with E1. We're already on that side. That's what we'll do. So 1/50th E1. E3 plus 1 over 2.5 E3. Okay, minus 1/2. So 1, negative 1 over, negative 1 divided by 2.5. Minus 1 divided by 2. Minus 1 divided by 50. All negatives, yeah. Negative 0.92. Negative 0.92 E4. Okay. Alright, that's all of our equations. Alright, I'm going to go get my calculator. You know, actually I'll use MATLAB. Yeah, I'll just use the application though. I have it on my desktop. Come on, buddy. Start up. I don't know, maybe the calculator's faster though. And like I have a test soon and I won't have MATLAB on the test, so what's the point? Let's do it on our calculator. Alright, we're inputting the system of equations into the calculator. Should I wait till it opens? Too much exposure. I'm gonna turn it down, it looks really bad. Oh man, yeah, close it down. It's using too much power. Another one? Oh. That's why. Another one? Oh. There. That was not good. We're doing everything. It's hot. Okay. Oh yeah. Alright, let's put our into our matrices. Let's put our system of equation into our matrices. 3 by 3. That is actually we need a 4 by 4. Holy smokes! Really? I can't really believe that right now, but I guess so. So point E1 0.7537. Enter. E2 -1 divided by 2.5. Enter. 0. Enter. E4 is 1 divided by -1 divided by 50. Divided by 50. Enter. Next equation, 0.7533. -1 divided by 5. E2, okay, good. Almost messed that up. And -1 divided by, whoops, -1 divided by 2.5. Did I get the other one negative? I did. 0, yep. -1 divided by 2.5. Shit, man, this is boring. Okay. Just dub. Negative 0.025. Okay. Oh man. Let's see, is there augment? Surely there is. So let's there has to be a way of doing this. 3 by 1. Yeah. 2 13.33. 3 by really? Oh, 4 by 1. 12.8. 12.80. Comsum? Are you kidding me right now? Comsum? I don't know what that means. Row swap. Row swap. What about columns swap? Augment. Let's see if we can look it up, figure it out. Because it's going to take too long to fill it in. I don't want to do all that. How to swap a 4 by 1 vector matrix into a 4 by 4 4 by 4 matrix to use Kramer's rule on the TI-84. Let's see. To use Kramer's rule, you cannot directly swap or paste vector into column. Instead, you must manually overwrite the specific column inside the matrix editor or use a system of equation solver app. Bro. Oh, I have to do it manually. That's some straight bullshit. Alright. We'll do it then. So edit the 4x4. So we'll start with solving for E1. 213.33. 12.8. Come on. 12.8. 0. Quit. Second matrix, math determinant, second matrix, 4 by 4, bang. Dub 1 equals negative 0.696. How long has it been? I've been trying to solve this problem for a long time. Too long. Damn, it's been way too long. Okay, I gotta be faster. Okay. Matrix, edit. Okay, we gotta put these numbers back in. So, 0.7537. That's why I should write it out first. And 0.75. Yeah, that's it. That's all I'm going to do. Negative 1 divided by 2.5. Fuck. 1 divided by 2.5. Negative 0.4. So negative 0.4, 0, negative 1 divided by 50. 0.02, 0.02. That's like all the numbers I need, I think. E1, there is no E1. Wait, oh, really? Oh, I messed that up. Okay, I'm gonna have to recalculate this. Oh well. 0. Negative 1/5, 1 divided by 5. Negative 0.2. 1 divided by 5, 0.2. E3 is 0.75 and negative 0.4. Okay, I gotta make sure I got my positives and negatives right. 1 divided by 2. Oh, wait, 2.5? Oh, it is. 1 divided by 2.5. 0.4. 0.2. Yeah, 0.2. That's a positive. 1/5 E3. 1/5 is 0.2. 1/5. 0.2, 0. 1/50th is 0.02. 0. 1 over 2.0.4. Negative 0.92. I don't know how I got that weird number, but there. Alright, these are wrong. Whatever. That's all wrong. Like my vector matrix or whatever the fuck you call it. 213.33. 12.8. 12.8. 0. There. Okay, that's my matrix. Bang. Okay, matrix, edit. We gotta solve for the first determinant again. So 0.75 is 0. Negative, oh wait, yeah, negative 0.4, 0.02. Negative 0.4, negative 0.2, 0.2, 0, 0.4, 0.2, 0.75, 0, negative 0.24, 0.92. Cool. Quit, matrix, math, determinant, matrix, bang. Okay. Equals 0.0222. Yeah. Dub, okay, dub not. Dub 1 equals, yeah, dub not. Whoops. Second matrix, there we go, edit, go back to that matrix, insert the vectors, 213.33, I don't know what we call them, 12.8, maybe that's not even the vectors, 12.8, 12.8, 12.8, 0. Alright, the determinant of that one is 32.276. Okay, and then so E1 would equal 32.276 divided by 0.0222. It's a very high number. I think that's good though. I guess maybe that's true. Let's see. I don't think that's right. 14.52. E1. 14.52 volts. I don't think that's right. Let's just solve for the rest of it. Shit, man. Doing this manually is bullshit. That's why I wanted to use MATLAB. So I want to use MATLAB. I don't have to do all that. But this is what I get on the test, so might as well get comfortable with it. 12.8. 12.8. 0, yeah. What the fuck? Are you guys following? Are we still streaming? Yeah. 48 points. Dub 2 equals 48.24. This divided by, should be up here, right here. E2 equals 2170. 7.1 volts. So V1, okay. That's positive, negative. Alright, yep, fucked up. Yep, I don't know how I'm fucking wrong. Holy fucking shit. Get the fuck out of here. Are you kidding me? Bro, what? How did you... how my logic made sense. My logic absolutely made sense. What is the fucking problem? Doesn't make sense how I'm wrong. Ah, fucking motherfucker. .8 amps. 3, 2.5, 3, 2.5, 50, 5, 2.5, 2, 640, positive, negative, 640, 640, positive, negative, 12.8. V3. Sure, we'll change it up, whatever. V1. Okay, 12.8. Alright. You gotta be shitting me. Alright, let's fucking do it. Let's get it done. That's 3, 2.5. I don't remember a 3 anywhere at all. So, oh yeah, I ripped it up. There's a 3 here. I don't remember a 3 anywhere in my previous equations. Motherfucker. Alright, that's fine. That's fine. Alright, let's do it again. So, E1, E2, E3. I guess this, E4. Sure. Yeah. Well, then I don't know. Would I not know that either? I wouldn't. Oh, shit. Okay. E4. No, I don't want to do that. Yeah, that's what I want to do. E4. I want to do the same thing again. Yeah, because then now I know this node. 640 minus E1 divided by 3. I better specify everything. Fucking dock me points for that. E1 minus equals E1 minus shit. No, I'm gonna put minus E1 minus E2. Whoops. E2 divided by 2.5 plus minus E1 minus E4 divided by 50. That's where it went. No. Alright, 640 divided by 3. I'm just going to put it in a fraction. 640 divided by 3 equals E1 multiplied by, let's see, equals 0. So plus 1/3 plus 1 over 2.5 plus 1 over 50. Plus minus 1 over 2.5 E2 minus 1/50 E4. Okay, that's one equation. E2. Yep, we have him obviously 12.8. Okay, and then we got E1 minus E2 equals C2 divided by 2.5 minus 12.8 minus E2 minus E3 divided by 5 equals 0. 12.8 equals, add it to that side, so E1, 1 over 2.5 minus, wait, no, that's it. Plus E2 multiplied by negative 1 over 2.5 minus 1/5 minus 1/5 E3 plus E 1/5 E3. Yeah. Okay, like that. Okay, another equation. E3. We have this. We have this. We have that.